Right, completing the square. Something you might have done in a previous class. Okay, suppose we need to solve x squared minus 6x minus 10. Find the zeros of this function. Okay, so now this will not factor. Okay, let's have a look down here. So first things first, we set it equal to 0. Okay, it won't factor. There's no two numbers that make negative 10 when you multiply, that make negative 6 when you add. You could throw this in the quadratic equation formula, but here's just another method. Now, here's what we do. Just isolate the x squared and the negative 6x. Okay, so I'm going to add a 10 to both sides, which gives me this line. Okay, here we go. So I'm going to complete the square on the x squared minus 6x. Now I'm going to show you some other examples before we kind of move on to this. Okay, complete the square on x squared plus 8x. Here's what you do. Half the 8. What's half of 8? It's 4. Then square it. 4 squared is 16. That's what I need to do to complete the square. Okay, how about this one? Negative 12. What's half of negative 12? Okay, it's negative 6. What's negative 6 squared? Positive 36. Now you'll always be adding because anything squared is positive. Okay, whether it's in positive 4 or negative 6. So remember, you half the integer next to the x and then square it. So now what does this mean? Well, if you were to factor this, you'd get this. X plus 4 times another x plus 4 or x plus 4 squared. And this is what we're aiming for, this parenthesis squared. If I was to factor x squared minus 12x plus 36, I'd get x minus 6 and another x minus 6. In other words, x minus 6 squared. Okay, that's why we're doing this. Let's go back. Right, so here we were. Isolated the x squared minus 6x. What's half of negative 6? It's negative 3. What's negative 3 squared? It's 9. This is why we add 9 to both sides, okay? So I have x squared minus 6x plus 9 on this side and 19 on the other. That's why I end up with this, okay? Now, the reason why we did this, I'm going to transform x squared minus 6x plus 9 into x minus 3 times x minus 3, which is x minus 3 squared. Now, here's why I do it. I can now square root both sides. Square root of x minus 3 squared is just x minus 3, the square root of 19, plus or minus root 19. So I end up with this. Now I just add 3 to both sides. I can't literally add 3 to root 19 or negative root 19. So just write it like this. And there's the answer. Okay, that's what I've got. You could put that in the quadratic equation formula. You get the same answer. Let's have a look at some harder ones. Now, first of all, we've got to look at this. Before we complete the square, we must have just a nice straightforward x squared. I can't have 2x squared or 3x squared. So here's an example. Right, well, at least let's get it into its standard form. Here it is by subtracting 3x from both sides. There we go. Okay, now I look at that. It won't factor. Okay, so I've got to do it like I did the previous one, completing the square. You could use the quadratic equation formula. Again, look, I've just iterated the x squared and the x part, okay? So I've added a 1 to both sides. Now, to get it to just a single x squared, I've got to divide everything by 2. So here we go, I've divided everything by 2. This is where I am now going to start and complete the square, okay? There's my starting point. Right, the problem with this is it's not a nice even number. Look, I deliberately used even numbers over there because you could halve it to a nice whole number and then square it. Here, even worse, it's a fraction. Right, what's half of 3 over 2? That's what I've got to do. Look, I've got to half this 3 over 2. Well, half of 3 over 2 is 3 over 4. If you don't see it, here it is. What's half times 3 over 2? Okay, it's 3 over 4. Or negative 3 over 4 in this case, because this is negative 3 over 2. So I halved it, and I got 3 over 4. What's 3 over 4 squared? Positive 9 over 16. Think about it. 3 squared is 9. 4 squared is 16. And again, it's positive. No matter whether it's negative or positive, when I square something, it's positive. So I'm going to add 9 16ths. I've just done the same as this. I halved an 8 and squared it to get 16. I've halved 3 over 2 and got 3 over 4 and squared it to get 9 16ths. And I've added it to both sides, just like I did in this one here, where I added 9 to both sides. Nicer numbers. Okay, so, but remember, the actual easy bit is this side. Because this, just like here, so remember this, x minus 6x plus 9 would factor into x minus 3 times x minus 3, x minus 3 squared. If you think about it, I just really took half of this negative 6 and put it here. So if I do half of negative 3 over 2, it's negative 3 over 4, which I found that earlier. Anyway, didn't I remember? So here, half of 6 is 3, and I squared it. Half of 3 over 2 is 3 over 4, so that's what goes in here. Okay, it's no different than that. Okay, x squared minus 6x plus 9 produced x minus 3 squared. That's just half the number, so half this number, I end up with negative 3 over 4. Look at it. Right, problem is that people hate adding fractions on this side. Well, 1/2 is 8/16 plus 9/16 is 17/16. I've still got to do what I did here and square root both sides. If I square root x minus 3 over 4 squared, it's just x minus 3/4, which is nice. There it is. But if I square root 7/16, I've got to write plus or minus the square root of 17/16. Sorry, okay? Well, that's the square root of 17, and the square root of 16, and the square root of 16 is 4. Okay, just work through this, have a look at this. Then I add 3/4 to both sides, and again, I would just write it like this, or this. It doesn't really matter. I'm just kind of finishing it off just like I did this one here. Okay, so just a bit more complicated. It deals with fractions and, you know, the problems with fractions. Okay, there you go.